Unit 9, Day 5 notes. Today we're going to talk about composite area and shaded area. And as the slide says, next class will be a test. So this is the last day of notes for this unit. A composite figure is two or more figures attached to form a larger figure. So there are many ways you can find the area of the entire figure. For example, on example 1, it's already divided for me into two shapes, so I'm going to use what is provided. I'm going to say this is shape 1 and this is shape 2. And in doing so, I can find the area of shape 1 and then find the area of shape 2 in isolation. And once I have both areas, I add them together, and that would be the total area for the entire figure. So again, I'm going to find the area of 1 and add it together with the area of 2. So figure 1, we know that the right hand side here is 7 inches. We need to know what the bottom and the top pieces measure. When you look at the larger figure on the bottom, figure 2, the entire bottom side is 13. So that means the entire top should be 13 as well. We notice that only 5 of it is already marked. So that means we have to figure out what is missing by subtracting 13 and 5, and you would end up getting 8. So this dashed part is 8. Together with the 5 should give you a total of 13. So figure 1 is a rectangle. And so the formula for the area of a rectangle is length times width. So to find the area for the figure 1, we're going to take 8 times 7. Now figure 2 is a square because the bottom side is 13 and the right hand side is 13. And so since they're the same, that means it's a square. And for the area formula, we're going to use side squared. So that would be 13 squared. And now we can grab any calculator to figure out the composite area. What I would do to save myself some time is to type it all in one step. But you can only do that if you have a graphing calculator. If you don't have a graphing calculator, then you would have to type it in individually. So I'm going to type it in exactly as I have it written down. So that's 8 times 7, not 77, 7, plus 13 squared. And the total area for the composite figure would be 225 inches squared. Alright, now for example 2, I could do the same thing we did in example 1 by breaking this figure into several figures. But that's not the route I want to go this time. It seems like that would be a much difficult route. So instead of doing that, I'm going to turn it into a much larger, complete rectangle. So in doing that, I essentially have 3 rectangles. I have this much larger one, And then I have these two smaller ones here. So by adding pieces to my rectangle, I'm going to have to subtract things later on. So at the end of the day, my goal is to find the area of the large rectangle, rectangle 1, and then I'm going to subtract the area of the two smaller rectangles. So the area of rectangle 2 and the area of rectangle 3. Since they're all rectangles, they all will be using the formula of length times width. So now let's find all the dimensions of each rectangle. So for rectangle 1, it shows us that the bottom piece is 18 centimeters, but that 18 only goes that far. So you have to look above to notice that to get all the way to the end, you would have to add 18 and this 5 up here. So the total distance of that side is 23. So from here all the way down is 23. There's a similar idea going on with the right hand side. From this top corner to here, it's only 13. So you have to take this piece into consideration as well, and that piece would be 2 centimeters. So 13 and 2 together make 15. So the sides, or the width, is 15. So the larger rectangle, we're going to take 23 times 15. Now we got to find the smaller rectangles. All right, rectangle 2, we know that this portion here is 6. To find this red piece, we know that the entire length from left to right is 23. And we're showing that there's 8 here and 8 here, so that's 16 out of 23. So we are lacking or missing 7. So 8 plus 7 plus 8 would give you 23. So the smaller the middle size rectangle, rectangle 2, would be found by taking 6 times 7. And lastly, the rectangle number 3, we're going to use these dimensions here, the 2 and this 5, so it's 2 times 5. And now grab the calculator. You can type it all in one step, or choose to do it in smaller portions. It doesn't matter. You'll get the answer eventually. I'm choosing to type it all in together. So it's 23 times 15 minus 6 times 7 plus 2 times 5, or 10. And you get 293. So the area of the figure is 293 centimeters squared. On number 3, we're going to find the area of the shaded portion. To find the area of the shaded portion, we're going to follow the directions as printed. It states find the area of the large rectangle and subtract the area of the smaller rectangle. Again, area of a rectangle is length times width. So the larger rectangle's dimensions are 19 and 7. And the smaller rectangle is 4 and 15. So let's grab our calculator and put that in. 19 times 7 minus 4 times 15. 73. So the area of the shaded region is 73 inches squared. For number 4, it tells us to find the area of the square and subtract the area of the four circles. Area of a square formula, again, is side squared. Area of a circle, we talked about last class, is pi times radius squared. And since we're finding the measure of 4 circles and they happen to all be the same, they all have the same radius, so we just need to find the area once and multiply it by 4. So for the square, our side is 10. So it's going to be 10 squared for the area. 4 times pi, and then the radius for our circles is 2. So times radius squared. And let's type this in our calculator now. So we have 10 squared minus 4 times pi times 2 squared. You get a roughly 49.73 inches squared. 49.73 inches squared. And this is our last problem. To find the area of this shaded region, we're going to find the area of the rectangle, length times width, and subtract the area of both triangles. The formula for a triangle is base times height divided by 2. And we're finding 2 triangles that have the same dimensions, so we're going to take this formula and double it. Now, if you take your base times your height and divide it by 2, and then go back and multiply by 2 again, you're essentially starting with your base times height, because think about it. If I take 2 steps forwards and then take 2 steps back, I ended up in the same position I started, because you really did not move anywhere. So what I'm saying at the end of the day is that these 2's will cancel each other out. So it would end up being length times width minus base times height. So the dimensions of the rectangle are 32 by 16. The dimensions for the triangle are 4 by 6. So let's grab our calculator and type this in. 32 times 16 minus 4 times 6. 488. So the area of the shaded region is 488 feet squared. And this concludes your notes for today.